In 1885, Adolf Baeyer developed his strain theory. Even by then, it was realized that some carbons had a tetrahedral shape and thus would have an optimal angle of 109.5 degrees. Baeyer took this information and realized that most rings would not have this ideal bond angle, and so should show angular ring strain. The graph's x-axis depicts the number of atoms in each ring. The left y-axis shows the difference between the ring bond angle and 109 degrees. So we can immediately see that a 5-membered ring seemingly has close to an ideal 109 degrees. Rings that are smaller than this have a very significant difference between their bond angle and 109 degrees, and rings that are increasingly larger than this have an increasing difference in their bond angle and 109 degrees. This difference in bond angle to 109 degrees should correlate to angular ring strain if the molecule is planar, that's to say flat. Okay, so there's the theory. How does this compare to a practical experiment? Well, if we take a molecule and place it in oxygen, combusting it will allow us to calculate the heat of combustion. This will produce carbon dioxide, water, and heat. On the right y-axis, we have the heat of combustion for a cyclic, that's to say ring molecule, and we subtract the heat of combustion for an acyclic chain or zigzag equivalent molecule. So if there is ring strain, we would expect this to give us a positive number, and if there is no ring strain, we would expect to see 0. So how does the theory compare to the practice? Well, not fantastic. We can see that on the left-hand side, the smaller rings, it's not miles off, but equally, we don't have a correlation. They are not following exactly each other. On the right-hand side, everything's gone to pot. It's awful. There's clearly absolutely no correlation whatsoever. So the Baeyer ring strain theory is wrong. The theory and the practice do not match, but the question is, why?